Okay, so I can proceed. Okay, I'm going to talk about the role of history of physics in science education in order to address the problem of trust in science. I am a physicist from University of Calabria down in southern Italy, and we are going to talk about some didactic path we have developed with some school in our region to address this issue. Okay. So science over about 4 centuries had an institutional authority within society. But recently, this authority of science has been criticized by some anti-scientific movement, things of anti-vaccine movement, flat earth, and other amenities like that, which are becoming a widespread problem. I think all of you are aware about this problem can undermine society's abilities to address several challenges we are facing. Can you see my slides? Okay.
Yes, we can. Yeah, they're great.
So the success sciences had over 4 centuries is because it is a social structure, in the sense that knowledge is established when consensus is achieved within the community. Consensus means that we are looking for matter of facts, experimental facts, upon which there can be no disagreement. Okay. And in this sense, the trust in science, as usually we define it, is the trust in the social process of scientific investigation. And we need to restore this trust in the sense that it is still the most reliable and authoritative way to produce knowledge of natural phenomena. And in this sense, I think it would be more appropriate to talk about trust in scientific research, which is maybe a semantic distinction, but it emphasizes the fact that we are building knowledge in a process of research. And this is particularly important because there are issues that are impacting our society, but for which science has not yet reached a consensus. So how can we restore the trust, and what can we do? Since the epistemological norms that govern the production of knowledge in scientific community have been established historically, this means that we need to develop a focus in science education in school about the methodological and epistemological norms that govern this production of knowledge. And this is particularly true for physics education, which is probably the most taught experimental science worldwide. So in the following, I'm going to discuss some didactic path that introduce an historical approach to the physics laboratory, so that students and teachers can focus on the social construction of scientific investigation, while still preserving content learning, because this is also important, of course, for example, for the building of scientific workforce. Here is, for example, a project we have developed with some school. We have collaborated with school. In Italy, schools can be very ancient, dating back to several centuries. And we have collaborated with several schools of our region to recovering instruments in their laboratories. Here you have some of these instruments, some of which date back to the 19th centuries. You can see, for example, from the materials that they've been used and from the design that they belong to different periods. The most recent of this one that date back to the 50s, so they can be defined. Most of them they can be defined ancient. Here you find some couple of publications where we have discussed this project, which is a project of work-based learning. I'm going to talk about that in the next talk. Means that students perform a work within school and within university. It is a working activity. Here you have some other example of instruments. With these they are also nice to look at, I think. I mean, this is Thomson experiments for the discovery of the electrons. You have some discharge tube, some electron diffraction. I don't know if you are acquainted with these topics, but I think this is simply nice to look at. So what we do is we integrate an extracurricular program, informal educational program within the formal curriculum. And most of these instruments works, but not properly because they are very old. They come without instruction. So what we do with students and teachers is to figure out if and how they work. So this creates an environment in which people, researchers from university, teachers and students have a peer-to-peer interaction, which are similar to distributed reasoning in scientific research groups, which is an activity of active learning technique that can be developed in formal school. So this peer-to-peer interaction is what we are looking for in order for the students to feel and to have a taste of what scientific research is. So we have developed with this instrument several didactic paths, which we that have been developed with three main requirements. That is the historical context of the instruments within their period of invention, a close connection with the school curriculum so that students can see the connection with what they are taught in schools, and also the societal or scientific research implication on scientific research or in everyday life of the topics we are going to deal with the students. Here you have an example. In this first picture, you have a reproduction of a vacuum pump of the 17th century, the Boyle pump, which was one of the 6 instruments invented in the 17th century that had a revolutionary role in the birth of experimental science. So with this pump, which actually does not work, but is there to be shown in the sense that we developed seminar and lesson to show how this instrument was used by Robert Boyle in order to establish what is an experiment, how it is performed an experiment, how it is successful experiment identified, and so in order to arrive to scientific truth, so that the students have an idea of what are the epistemological norms that govern this experiment, the history of these experiments. The next step is represented here, which is a modern vacuum pump used for didactic purpose, so that the student can perform some experiments so that we can preserve content knowledge about vacuum, for example, just in this case. And this is instead a vacuum pump that is used for actual scientific research in our laboratories, so that students can also interact with researchers performing material science studies to discuss the motivation and the societal implication of this research. In this way, we start from the original Boyle question: why do experiments lead to truth? And so students' reflection are guided to the issue of acceptable methods of knowledge production. And the thematic path connect the history of physics to the curriculum, to things they are studying in schools, to topic of actual research. Here you have another example. For example, this is a steam engine, which can connect with the history of industrial revolution and stuff like that. Then we perform some experiment. This is a Stirling engine, so that we can study thermodynamics with these instruments. And the Stirling engine is what is actually used here, for example, in this solar panel, which is mounted in our university. Again, you start with an historical question, then you study some physics, in this case thermodynamics, the efficiency of the cycle, and then you try to connect with actual research and societal problems. This is another setup, which is the transmission of electromagnetic waves. This is the experiment that was performed first by Guglielmo Marconi in the end of the 19th century. And this is what gave birth to the actual modern wireless communication, so that we can connect with the smartphone and with the use student makes of this kind of communication, which originated from a setup like that. So that, to conclude, I have presented some paths that introduce students to the history and philosophy of science, while simultaneously exposing them to the interaction with the research environments on one side, and to the practice of scientific research, while at the same time preserving the original focus of school education content knowledge. We need to foster the uptake of this kind of approach because they are still poorly applied, and we have used some policy interventions, some reform intervention that have been done in Italy, for example, the work-based learning, which is mandatory for all students now, and it is a way to establish this kind of connection through informal education programs. And in the end, the idea is this, that if students know how science cope with problems and especially with wrong beliefs and with ideological biases and so forth, they are probably going to trust and support that science is not yet serious alternative with respect to the problem of producing reliable description of the world around us. So thanks for your attention.
Thank you, Professor.